In this question here, he asked me about proof that integral secant to the power n x dx equal 1 over n minus 1 secant to the power n minus 2x tan x plus n minus 2 over n minus 1 times integral secant to the power n minus 2x dx. After that, after I prove this statement or this law, I will use it to find integral secant cubic x dx. So I will start my proof from the left side, which is secant to the power n x dx. First of all, I will write secant to the power n like this. Secant to the power n minus 2 x times secant square x dx. Because in multiplication, the powers will be added. So n minus 2 plus 2, it will be n. So this is the correct statement. Now from this integral, I will use integration by parts to solve it. I will take u secant to the power n minus 2, and I will take secant square x as dv, because secant square x, I know the integral of it, which is tan. So u equal secant to the power n minus 2. Give me that du equal, I will make the derivative as a chain rule, so it's n minus 2 secant to the power n minus 3 times the derivative of secant, which is secant x tan x dx, which is equal n minus 2 secant to the power n minus 3 times secant, it's secant to the power n minus 2 times tan x dx. So du, it will be n minus 2 secant to the power n minus 2 tan x dx. Now what about dv? dv, it's secant square x dx. So v equal integral of secant square, it's tan. Now I will back to my integral I will use integration by parts. So u dot v minus integral v du, which is, u times v, u, it's secant to the power n minus 2 times v, which is tan x, minus integral v, which is tan x, times du, which is n minus 2 secant n minus 2 tan x dx. Now, if I look here, I have tan x, which is mean tan square x. So secant to the power negative 2x tan x minus integral tan times tan, tan square x times n minus 2 times secant n minus 2x dx. Now, tan square x, I will replace by secant square x minus 1 as an identity. So my integral now I will be secant to the power negative 2x tan x minus n minus 2, because it's a constant, I will take it outside, so n minus 2 integral tan square x I will replace by secant square x minus 1 times secant to the power n minus 2 dx. Secant to the power n minus 2, I will take it inside bracket, so I equal secant n minus 2 x tan x minus n minus 2 integral secant square times secant to the power n minus 2. I will add the power, so 2 plus n minus 2 will give me n. So secant to the power n x minus 1 times secant to the power n minus 2, it's minus secant to the power n minus 2x dx. After that, now here I have subtraction between two terms, so I will distribute the integral on this, so secant n minus 2x tan x minus n minus 2 integral secant to the power nx dx. Minus minus, it's a plus, so plus n minus 2 integral secant to the power n minus 2x dx. This integral now, this one, I will take it to another side, because integral I is integral secant to the power n x dx plus n minus 2 integral secant to the power nx dx equal secant n minus 2x tan x plus n minus 2 integral secant n minus 2x dx. If I take integral secant nx dx as a common factor, I will have from here 1 plus n negative 2, like this, equal the right side dx. Now 1 plus n minus 2, this term will give me n minus 1. So I will divide all over n minus 1. So integral of secant n x dx equal 1 over n minus 1 secant n to the power secant to the power n minus 2x tan x plus n minus 2 over n minus 1 integral secant to the power n minus 2 dx. Now I will look for this if it's correct answer or not. I will back my question. Let's see here. It's 1 over, n minus 1 secant to the power n minus 2x tan x plus n minus 2 over n minus 1 integral secant to the power n minus 2x dx. So I have the correct answer here in this proof. Now, this law, I can use it to find integral for secant cube x dx. So the value of n now, it's a 3. So 1 over 3 minus 1, it's 2. Secant 3 minus 1, it's 1. Secant x tan x plus 3 minus 2, it's 1. 3 minus 1, it's 2. Integral secant x dx. Because 3 minus 2, it's 1. Now, integral secant x, we know it before, so half secant x tan x plus half ln absolute secant x plus tan x plus c. That's it.